Ignition will commence in 30 seconds. Warning. ICAN laser ignition will commence in 20 seconds. Warning. ICAN laser ignition will commence in 10 seconds.
And so ICAN's search for what lies beyond the Higgs boson begins. The most powerful laser ever conceived is switched on. This scenario belongs in the future, yet the research required to try and make it happen has already started. But exactly what is ICAN?
ICAN is an international project to try and develop a laser which is a combination of many fibre lasers into one in order to provide us with the advantages of short pulse lasers, but also the advantages of high average power that you can get from fibre lasers.
We know with short pulse laser we can really produce already gradients. Very high gradients, maybe 1,000, 10,000 times higher than what's possible with conventional technology.
Very high-powered lasers have been tested as possible particle accelerators, but with mixed success. Although the laser pulse they can produce is massive, having fired once, the machine has to stop before it can do the same thing again. This is called the repetition rate.
Now, existing huge laser experiments fire sometimes only 4 times a day. We're now talking about the possibility that you could do this with an average power so that it's on all the time.
The reason this is possible is because of the unique way the laser is conceived.
What happens is you start with a single seed laser and then you split that into 8 different channels, amplify, split those channels into 8 and then split those channels into 8 until you get up to, say, 512 amplifiers. And then those 512 amplifiers, the beams have to be synchronized and brought together to make a single beam. In practice, what we're trying to do is build on the fact that within telecommunications you have a lot of components which have already been developed. And so the idea of making, say, 10,000 lasers for a single project is much easier because the infrastructure is already there.
The fibre laser brings for the first time the idea that you could take 1 million of these and combine them together to achieve what no other laser can do. So you have an additional parameter of using millions of lasers together to achieve a new form of laser. And this has made all the difference to the idea of wake field acceleration for the next generation of certain accelerators, for example.
As a particle accelerator, ICAN relies on something called wake field acceleration. When a boat moves through the water, it leaves behind a turbulent wake, and for the adventurous this provides an opportunity for surfing. Much the same thing happens when a laser pulse passes through a gas plasma, and the wake drags surfing electrons behind it, accelerating them as it does so.
What is very interesting about these wake field accelerations, the limit right now of conventional accelerators is the breakdown of material.
And so the intention with ICAN is to then use that technique, but use it at very high repetition rate and chain those amplifiers together to make a particle accelerator that's at very high electron energies.
This Higgs discovery it's a phenomenal discovery. What people have done at CERN is absolutely incredible. is the fact that now we found it. Okay. And so we have really to look at what's beyond it, because certainly there is something else beyond it.
What is beyond the Higgs boson remains unknown, but each new discovery takes us closer to the greatest mystery of all. What happened in the beginning?